Hi, my name is Paul Hutchings with Simple Steps to FinancialFreedom.com, and I want to welcome you to this short video on compound interest. Albert Einstein said that compound interest is perhaps the greatest mathematical discovery of all time. It's also been said that those who understand compound interest are destined to collect it, those who don't are doomed to pay it. Key point in understanding compound interest. Interest is always calculated on principal, and the major difference between understanding simple and compound interest is the definition of principal, so keep that in mind. With simple interest, your initial investment is the principal, and it always is the principal. In this example, you invest $1,000 at 10%, so $1,000 is your principal. At the end of year one, you earn 10% on the principal, which is $100. At the beginning of year two, your principal carries over from the previous year, $1,000. At the end of year two, you earn another 10% on the principal. This process continues each year until the principal balance is withdrawn and the investment ended. The important thing to note is that with simple interest, the principal never changes, and therefore the interest that's calculated on that principal is always the same. Compound interest starts out the same way. You invest $1,000 principal. At the end of year one, you earn 10% on the principal. Here is where things start to get a little different. Remember, with simple interest, your principal never changes. With compound interest, both the principal and the interest from year one become the principal for year two. In compound interest, the principal and the interest from the previous year are compounded into the next year's principal. When we now go to calculate interest for year two, it's not just on the initial investment of $1,000. We will also calculate interest on top of the interest earned in year one, and therefore the interest amount is higher. It's now not just $100, but it's $110 because it's calculated on the principal, which was $1,000, and the interest, which was $100. So now we're calculating on $1,100, which gives us the interest of $110. This will now give us our principal balance for the beginning of year three. The magic of compound interest is that each period, the interest is compounded into the new principal for the next period, and therefore the interest grows and the principal grows, and they compound on each other, getting bigger and bigger. Key point, the bigger the rate and the longer the compounding period, the greater the snowball effect. Let's take a look at what happens a few years down the road with the example that we just used. You invest $1,000 at 10%. On the left side, we're going to use simple interest, and on the right side, we're going to use compound interest. As you can see, at the end of year one, it's exactly the same. You've got $1,100 for your investment value. Year 5, they're still fairly similar. Year 10, we're starting to get a little bit of a difference there. Year 20, now the compounding has actually doubled the effect. Year 30, we've got 17,000 versus 4,000, compound versus simple, and jump down to year 50. Simple interest would return $6,000 over 50 years, and compound interest would return $117,390. Absolutely amazing. Moral of the story, earn compound interest, don't pay it.
All right, so a lot of this first stuff is basically what we already talked about or you heard in the video. So you can read through that and kind of just to help you understand compound interest maybe a little bit more. But we're going to go ahead and take a look at our two formulas here. So we have compound formula, and we have all of its parts listed here. Then we have a continuous. So let's talk about the difference here. So when we talk about the number of compounding periods, when we talk about annually, that number is going to be for n is going to be, when it's annually, only once. Okay, semi-annually meaning 2 times a year, and then quarterly 4 times, and then monthly, obviously there's 12 months in a year, so it's compounded 12 times. Daily, so we use 365, round up. And then continuously, there is no n. We're going to go to our formula up here because it's compounded continuously, constantly. So we're going to go ahead and look at just a couple of examples together. So for this first one, our initial amount is going to be 500, and then, or sorry, 5,000, and then our rate we want to use as a percent, changing it from a percent, to a decimal. It's those allergies getting to me. So 0, 6, 2, 5. So divide it by 100 or move that decimal place 2 places to the left. Time. So for this one, we're going to think about, well, we're going from 2000 to 2012. So that difference is a difference of 12 years. Are we compounding or are we going continuously? Well, it says compounded quarterly. So that means that we are using compounded growth, that formula. And if it is compounded quarterly, then our n, which we should have down here, is 4. So for our equation, we are going to have 5,000 and then a 1 plus, and then we put our rate, 0.0625, over our n, which in this case is 4. And then we take it to the nt power, so n times t up here. So now we're just going to go ahead and type this into our calculator. So you're going to do this inside the parentheses first, maybe divide that here, add it to 1, then take it to the 48th power, and then times it by 5,000. And we get 10,523.79. And you can go ahead and work backwards, like if you want to figure out when it would be equal to 10,000, we would just set up this formula equal to 10,000, and instead of the time, we would put a t, and we would work backwards, and that's when we would use our log. So we're going to go ahead and do that one, just so you can see how that happens. And let me get my pen working. All right, so if we want to figure out when it's going to be, equal to 10,000, then we set up that same equation. I don't know what my pen is doing here. I'm going to revert back. Hold on. And we have 1 plus, it's still doing that thing. Technology. So we stick our 4 is still here because that's how many times it's compounded, but we don't know our time, so that's when we have that t up there. And then this is 625 for our so everything else is the same. So we're going to work backwards. We're going to divide by 5,000. And then we have, there we go, equals, going over the whale picture, parenthesis 1 plus, and let's go ahead and combine our parts here. So inside the parentheses here, it's going to be 1.015625 to the n to the 4t power. So now what we're going to do is we're going to rewrite this. So we have a base, we have an exponent, and we have it equal to something. So we're going to use logs. So log, what's our base? It's the same base as this. So 1.0562 oops, I forgot a 1 in there. And then it's going to be to our total is going to go inside, and then equals our exponent, 4t. So now what we're going to do is we're going to use our calculator to finish solving this. So divide by 4, and we get t alone. So in our calculator, we're going to do log with this base of 2 and divide it by 4. Now we can't always type in a base that's not 10 in our calculator, right? So we have to use that change of base formula. So it's going to be log over log. And then we have our base on the bottom, so 1.015625. And then we have our kind of answer, what's in there, 2 on the top. So this, all of this is going to get us the log part. But don't forget to divide by 4 after you do that to get our t. So a little tricky to work backwards, but you can do it. So let's go ahead and type that into our calculator. And we wind up with 11.18 years. So pretty close to 11 years just after that, then you'll get to that 10,000. All right, so I want you to try number 2. We can check it in class. We're going to do a couple more in class as well, but I just wanted you to get the idea of seeing those formulas. Which one I really want you to try that's going to be new at continuous growth is number 5. So if you want to go ahead and try number 5, I can find it here. That one is going to be continuous. So you're going to use that formula that's P times e to the RT power. So go ahead and plug in all of your parts, making sure to multiply the R and the T and taking it to that E power. There is an E button on your calculator if you look for that. So try that. We'll go over those in class, a couple more examples on block day.